Hello everybody, this is Dr. Christopher White, and in this presentation we're going to continue looking at sedimentary environments and sedimentary rocks. So in this presentation we're going to look at some of the common non-clastic sedimentary rocks, and we're going to think about how they formed. Now when it comes to non-clastic sedimentary rocks, they typically fall into two broad groups. The first group is a group which is produced due to chemical reactions. And those chemical reactions can be due to water evaporating away or the mixing of two different fluids with different compositions. Then the other group are non-clastic organic rocks, which are related to organic processes. So in that instance, these are non-clastic sedimentary rocks where the rock is formed due to the accumulation of material of an organic source, and this could be anything from shells and skeletons all the way through to undecomposed organic matter. So to begin with, we're going to look at a couple of examples of rocks which form through chemical reactions. So you can see this area here, and you can see it has this rather nice white colour to it. So this is referred to as a salt flat, and so this is an area that was once covered by either fresh or salt water, and this fresh or salt water has evaporated away. Now the thing is when water evaporates, it's the water molecules that go into the air. They cannot take the stuff which is dissolved in the water up into the atmosphere. So for instance, if you have salt water, you evaporate away the water, but the salt which is dissolved in that water cannot go with it, and so it has to be left behind. And so as more and more the water evaporates away, eventually you get to a point where the minerals will precipitate out of the water and they will precipitate onto the floor of the lake or the sea. And we can see this in the form of this salt flat here. So this was an area that was once covered by water. That water evaporated away, and the salt which was dissolved in it got left behind. And this is a class of rock which we refer to as evaporites, because evaporation is the primary control. And the rock which is being produced in this instance is something which we refer to as rock salt. And if we look at this picture here, you can see the rock salt as these white spots. So this is going to be crystals of the mineral halite. The next type of sedimentary rock which is being formed through a chemical reaction is a type of limestone which we refer to as travertine. And this type of rock forms in environments where we have one of two things happening. The first possibility is that we have water which has been circulating around underground coming towards the surface, and this water that's coming towards the surface contains dissolved calcium carbonate in the water, and as that water is rising up, the temperature starts to drop. Now when the temperature starts to drop, it causes the solubility of calcium carbonate to decrease. So you're probably thinking, okay, what's he talking about? So let's think of an example. So if I take myself a glass of water and I start putting salt into that water, well, I put teaspoon after teaspoon after teaspoon of salt into it. The first few teaspoons of salt are going to dissolve in the water. Once I'm, several teaspoons in, on the other hand, the salt is going to stop dissolving in the water. The water has become saturated with salt. It can't dissolve any more salt in the water. However, if I take that glass of saturated salt water and I put it on a hot plate and I begin to heat that glass up, as the temperature of the water rises, you will suddenly see that the amount of salt that it can dissolve begins to increase. So by heating up the water, I am increasing the solubility of the salt in the water. So think of the reverse situation. I have a hot water that's been circulating underground, and this hot water starts to rise towards the surface, and as it's rising towards the surface, it begins to cool. As it cools, the solubility of certain elements or certain minerals which are dissolved in that water will begin to decrease. And as the solubility begins to decrease, the water has to get rid of the excess. And so it does that by crystallizing out minerals. So in the case of travertine, we have a hot water that's rising up from underground, it's cooling down, and the amount of calcium carbonate that the water can hold in solution is decreasing as the fluid's temperature gets lower, and so it has to kick out that excess calcium carbonate, and by doing so it ends up forming a fine-grained calcium carbonate rock which we refer to as travertine. Now, the other option is that once again we have a calcium carbonate bearing water which has been circulating around underground, rising towards the surface. But in the other model, what happens is as this water rises towards the surface, it mixes with another water. And the mixing between these two waters of different compositions encourages the calcium carbonate in the first water to exit solution and form solid calcium carbonate crystals, once again producing travertine. So in the case of travertine, it can be caused by a couple of routes, either fluid mixing, which is the second method I described, or simply through fluid cooling, which was the first method I described. So then we have rocks which can be formed by organic processes. And of course, the classic rock that's formed by organic processes is limestone. So limestones are produced by an accumulation of calcium carbonate rich shelly material. So that can be stuff like corals, it can be, oyster shells, it can be shells from other animals, it can be the skeletons of animals, all accumulating in an area over a prolonged period of time. So as all this shelly material begins to build up, we form a layer which is very, very rich in calcium carbonate. And then what happens is obviously we take that layer, we bury it, we compress it, we compact it, and as the rock gets buried deeper and deeper, the temperature begins to increase. And as the temperature begins to increase, it causes the calcium carbonate in the shells to recrystallize. So the shells break down. And so what happens is you end up taking these nice fragments of shell, and they break down to form these fine-grained calcium carbonate crystals that we can see here as the white material. Now, not all of the bits of shell will break down, and if some of the pieces don't break down, we will see them preserved in the rock in the form of fossils. So limestones, once again, are due to the accumulation of calcium carbonate rich material due to life, organic life. Another type of rock which is the result of organic life is coal. So coal forms in environments where you have waterlogged ground, you have boggy ground essentially. So think of someone like the Florida Everglades would be a classic example of that, the kind of conditions you're looking for. So in those environments you have waterlogged ground and you have lots and lots of organic material. So when the plant dies, it falls into the water and it sinks down to the bottom. Now normally you would assume that that plant would decompose and that would be it. However, because you are in the environment which is so rich in organic material, there's so much of it falling into the water that a lot of the oxygen in the water gets used up because there's so much decomposition going on, the oxygen gets exhausted. And so this means that some of the water, especially the water down towards the bottom of your bog, for instance, begins to get very, very oxygen poor. So there's very little oxygen in it, which means decomposition cannot take place. And so this means that any organic material, so any plant material that falls into that environment will not decompose. So over time, the amount of plant material begins to build up and up and up. And remember, it can't decompose. So that plant material just sits there. And eventually that layer of plant material gets buried deeper and deeper and deeper. It gets compacted, it gets compressed, it gets heated, and eventually it gets liquefied and the plant material turns into coal. So limestones and coal, should I say more accurately, limestones with fossils and coal are the result of material which is essentially gathered due to organic processes. So now we're going to look at 4 other common non-clastic sedimentary rocks, and we're going to think about how they form. So the next one is gypsum. So gypsum is essentially it's a calcium sulfate mineral, and gypsum, like the rock salt that we saw on the first slide, forms due to evaporation. It's an evaporite mineral. So once again, when we have our salt water or our fresh water evaporating away, within that water you are going to have some calcium sulfate dissolved in the water, and so as the water evaporates away, eventually that calcium sulfate will be forced to precipitate out, and it precipitates out in the form of gypsum. So it's not uncommon to find gypsum and rock salt, which is the mineral halite, together in the same sequence of rocks which have been produced due to the evaporation of a body of water. So next we have the rock chalk. So the rock chalk is actually another type of fossiliferous limestone. However, the fossils that are making up the chalk are tiny, they're microscopic. They're typically a type of floating microorganism which we call a coccolith. And it just so happens these coccoliths, these tiny organisms, have shells made of calcium carbonate. Now when a coccolith dies, the organic portion of the coccolith decomposes. However, the calcium carbonate shell does not, and it will slowly float down onto the seafloor where it will begin to form a layer. Now if you have, millions, hundreds of millions, billions of these coccoliths living in a relatively confined area, and they're dying of course every day, in the thousands, in the millions, all of those bits of shell are slowly falling down and raining out onto the seafloor, and slowly over time they'll form a big thick layer of shelly material. And if you take this layer and if you begin to lithify it, you will turn it into the rock which we call chalk. Now if you want to see what I'm talking about, I would strongly advise you to just go to Google and Google chalk microscope, and you will see some absolutely spectacular images of the types of shells which chalk is made from. It's quite a spectacular rock at a microscopic scale. So the next type of sedimentary rock we're going to think about is dolostone. Now dollostones don't form as a primary rock. The mineral they're made from is a mineral called dolomite, and it's a calcium magnesium carbonate. So compare that to something like chalk, which is made of calcium carbonate, the mineral calcite. So in the case of a dolostone, what's happening is you're taking a limestone, like the limestone we can see here, and during the lithification process, the process of turning into a rock, this calcium carbonate rich limestone comes into contact with a fluid that contains dissolved magnesium. And so the calcium carbonate limestone reacts with the magnesium bearing water, and it produces dolostone as a byproduct. So a dolostone is essentially a type of altered limestone. The final type of rock we're going to look at is chert, also sometimes referred to as flint. Now chert can form in one of a couple of ways. The first way you can form chert is like chalk, but in the case of chert it's not a build-up of coccolith shells, it's a build-up of shells from an organism called diatoms. And diatoms make their shells out of silica, SiO2. And so once again, when they die, the organic portion decomposes, but their shell slowly sinks down and settles out onto the seafloor. Once again, if you're in an environment where you have millions or billions of these organisms in the seawater, and so they're dying in very large numbers, and so that means over time you have an accumulation of these microscopic shells on the seafloor, and eventually it can lead to the formation of a very thick layer of silica-rich shelly material, which then gets lithified and ends up forming a layer of chert. Now the other way you can form chert ends up forming what we refer to as nodules, so just fist-sized lumps of chert, and that tends to occur when you have a water which contains lots of dissolved silica rising up and coming into contact with another fluid, another water of a different composition, typically seawater. And so what happens is as this silica bearing water rises up, it comes in contact with the seawater, and the two of them mix, and it produces a chemical reaction that encourages the silica to come out of solution and crystallize to form chert. And the chert that's produced by this way will often form nodules, so essentially, as I said, fist-sized lumps, which we often refer to as flint. All right, thank you for watching everybody, and have a good day.